Okay, in this video I want to talk a little bit about the domain and range of a quadratic function. So in order to get started, I'm first going to take this quadratic function and rewrite it in our standard form. So a is 1, b is 6, c is -9. I'm going to use our formula to find the vertex and the standard form. So h is minus b over 2a, which would be minus 6 over 2 times 1, -3. K is the corresponding y value. I guess I should be writing this down just to emphasize the fact that h is just the x coordinate on the vertex. K is just the y coordinate on the vertex. So when we're seeing those two, h and k, we should be thinking x and y. Before I continue the problem, I'm going to rant a little bit more about this. So if I'm giving you a word problem that asks you to find a vertex or something like that, keep in mind that your h is really going to be an x number. So if x is pounds of salt, then okay, h equals -3 would be how many pounds of salt. This is a terrible example. If y is, height of a ball, then your k value that you find would be a height of the ball. I should now come up with an example where we have height of the ball as a function of pounds of salt, and negative pounds of salt makes some kind of sense. That would be so exciting. Okay, anyway, back to the problem. So we found our h, which is minus b over 2a. We want to find our k, which is just plugging our h into the formula. So we know h is -3, so we have -3 squared plus 6 times -3 minus 9. Okay, so -3 squared would be positive 9. 6 times -3 is -18, and a minus 9. And notice that 9s will cancel and get -18. Okay, so right there I can say what the vertex is. H comma k is -3 comma -18. And also our standard form would be f of x equals a is 1, x minus h. X minus h would be x minus -3. I'm going to write minus negative as a plus 3. Plus k, and plus k is plus a negative, so it would also end up being a minus. So stare at the formula here versus the formula for a x minus h on a squared plus k. Notice the signs look a little weird, but that's because we had some negative numbers in our formula. Okay, so why did I go through all this song and dance to find the standard form? Well, because once I have it in standard form, we should recognize this, a x minus h quantity squared plus k, as just being a transformed version of y equals x squared. This is exactly a transformation of a simple parent function y equals x squared, where h and k represent two shifts, and a represents some amount of stretch. And potentially, if a is negative, it might also represent a reflection. Okay, so let's think about that for a second. If a is a positive number, then from my parent function, y equals x squared, I will stretch it out perhaps, but I'm not flipping it upside down. So if a is positive, it should still be a parabola pointed in the normal direction. So anytime I see a is positive like this, we're going to end up with a shape that looks like a standard parabola with some amount of steepness. I don't know how steep it's going to be. If a is a negative number, then again, maybe there's some amount of stretch, but if a is negative, then at some point we also have a vertical reflection, a negative number multiplied on the outside. And so a vertical reflection of a parabola would end up looking like a parabola facing downwards. Okay, now I'm ready to say why exactly this ties into the original question, domain and range. I could have answered half of that question right off the bat, what's the domain? Because the domain, there's no dividing by zero, there's no square roots of negatives, our domain is just all real numbers. And this is actually going to be the case for any quadratic function. The domain of any quadratic function is minus infinity to infinity. So it's kind of boring in that sense. They're always, you can plug any number into a quadratic function. The range, however, is interesting because only certain numbers are going to be in the range. We have not really talked much about range outside of times that we could draw a picture. If we can draw a picture, then we can figure out the range because it's just what are the y values that we're actually hitting. This is a scenario where we understand the situation well enough that we can draw the picture and we can figure out what is the range. So I'll go back to my exact example. We have a is 1 and the vertex is minus 3, minus 18. A is 1 means it opens upwards, and minus 3, minus 18 means it should be hitting its vertex at that particular number. So if our vertex is minus 3, minus 18, and we're opening upwards, it should look something like this. I don't really care exactly how it looks, but if you look at it, as far as what y's are we going to get, the lowest y we're ever going to see is this negative 18. That's going to be our minimum, which is the k value of the vertex. But we keep going up and up and up because the parabola continues going upwards in both directions. So our range would be all numbers from negative 18 up to positive infinity. And that's always going to be the case, that the range is k, comma, infinity, if a is positive. If a is negative, we have an upside down parabola, and then for an upside down parabola, our range would be minus infinity up to whatever value k is. So looking at these two pictures, I can actually say what the range has to be. K to infinity, since we're going from whatever this height is up, and in this case minus infinity to k, because we're going from whatever this height is down. And so this is a case where we have a maximum if a is negative. This is a case where we have a minimum if a is positive. And again, the domain is always going to be minus infinity to infinity. That should be really simple. Okay, hopefully that makes sense. I'm going to stop the video there.